Hello all. Today we discuss about 2:4 decoder, its architectural definition using VHDL coding, and draw the technology schematic, RTS schematic, and simulate the test bench waveform. So first of all, it is noted that this is enable input. The 2:4 decoder there have one extra input known as enable input. This A is the control input. This is 2:4 decoder. That's why these input are from 0 to 1, and that there are 4 output from 0 to 3. And this enable pin is active high. That means when this enable pin equal to 1, then the decoder will be selected, otherwise not. So here A and enable are in the process, are taken in the process. Process is the one statement in a VHDL programming. So now begin here. First of all, x assign equal to 1, all 1. Then now if enable equal to 1, then the case is started. When the case, if this A1 is 0 equal to 0 0, then output x0 equal to 0. That means this is active low decoder. When 0 1, then equal to 0. Otherwise, and the other output equal to 1. When 1 0, then this equal to 1. When 1 1, this equal to 1. And when any other combination are applied, then all output are in 1. Why all output equal to 1? Because this is active low decoder. For active low output, it is noted that for active low output decoder, if the output is not selected, then the status of the output equal to logic 1, and if selected, then the status is 0. This is the end of if statement, this if statement, this, and then the process end, and then the VHDL. Now check syntax. This check syntax shows there is no error in this command. Now this is the technology schematic. This is the internal architecture of the 2:4 decoder, and this is the RTL schematic. This is an RTL schematic, and now we simulate this model using test bench. Simulate behavior model, and after some time this window is open. Here we show that 2 input A1 is 0 and 4 output. They are 2 input. Now if we change here the input equal to 0 0, then we know that the output, these are the output, this 0 equal to 0. Otherwise, when these input equal to 0 0, then these output equal to logic 0 and remaining output equal to logic 1. Okay, now check it. Okay, here have some status will be shown that the input equal to 0 0, but if we A1 equal to 1, these output equal to 1 and these output equal to undefined. Now if we put here 1 and run again, and the 4 1 0, then this output are not changes. They have some problem. Okay, because first of all this enable equal to 1. Okay, here enable is undefined. Okay, now see that if enable equal to 1 and these input equal to 1 0, 1 0 means 2, then 0 1 2, these 2 output equal to logic 0. Here show that the output 2 equal to logic 0. And when these here, sorry, and here if we changes the logic from 0 to 1, then it is shown that, okay, just a minute, force constant, so this is 1 1, and run it. Okay, now this is shown that the 3 output x of 3 equal to 0. Okay, why? Because this A1 A0 equal to 1 1. 1 1 means y3 output equal to 0, and if enable equal to deactivated, see that here if enable equal to 0, logic 0 apply, then there is no output will be selected, because all output equal to 1, because enable equal to 0. Okay, so this is an active low decoder and the test bench waveform, and here the timing state, each and every timing state in the PS picosecond. Okay, so So this is an 2:4 decoder, their internal architecture, the test bench analysis, and the output individual logic signal for the different condition of input and the enables.